Polynomial test review. Number one, this step is good. This one is good. So he factor out the x squared from here, and he factor out the number 8 from there. So now he's going to factor out the x plus 2. So the mistake is this steps over here because he has 2 x plus 2 when it should be only 1. Okay, so it shouldn't be there. So if you only have one group of factor x plus 2, so the answer is x equal to negative 2, and the multiplicity just should be only 1. So that is a mistake. All right, moving on to number 2. So now x to the 4, we can write as x to the second, so keep in mind x to the second to the power second again, so that's going to give you x to the 4. Here I factor this polynomial by finding two number time to get negative 54, and when I add, I get negative 3. So that will be, so again, it's x squared, now it's x. So x squared, and then I'm going to have another x squared over here. So two number time to get negative 54, 9, and 6. But we want negative, so it'll be negative 9 and positive 6. So now let's check the work. Negative 9 times 6, negative 54. Negative 9 plus 6, negative 3. So we got both numbers correct. And now to find the 0, we need to make this equal to 0. Then we're going to solve each of this, factor by setting them up equal to a 0. I'm going to move negative 9 to the right, so positive 9. I'm going to check the square root. So x is going to be equal to plus or minus 3. So whenever you check the square root of a positive number or any number, you're going to have a negative and a positive. So do not miss this out. And for this equations, I'm going to move the positive 6 to the right, so be negative 6. Then I'm going to check the square root. So here the negative 6 is positive 6 times negative 1. So negative 1 is I squared. This is going to be x. Then I'm going to have the I plus or minus square root of 6. So now here I have two real solutions and I have two imaginary solutions. So the degree of this polynomial is 4. This number is over here. So that number is the degree of the polynomial. So we expect to have four solutions, and we do have 4 solutions. All right, so we just have to expand this like we learned in class. So 343, if you want to take the cube root of 343 first, that's what you should have done. Okay, so let's take the cube root of 343. That's going to give you 7. So first we want to know what make the cube root. We want to take the cube root of 343 to get 7. And we also want to check the cube root of 125. I believe it's going to give you, is that five or 5? Okay, so now I'm going to rewrite my expressions as 7x3 with the bracket minus 5 to the third power. So do not forget that we learn two different sum and the difference q formula, that if a third minus b to the third will be equal to a minus b, and then the factor of a squared plus ab, and then plus b squared. If we have aq plus bq, it's going to equal to a plus b, and then a squared minus ab plus b second. So try to memorize those two formulas if you can. It's very important when you take in the SAT or ACT, or when you go to college. You always going to need how to expand the sum and the difference cube into two different factors. So I'm gonna think of the AQ and the BQ here. Then this is what I'm gonna get. 7x. It's a minus, so gonna be minus 5. And then be 7x. Keep this in the bracket with the square, and then plus 7x times 5 plus 5 second. Again, I'm just follow uh, exact what was from the formulas. This one, okay, I'm going to use um, 3a for this one, problem 3a, okay, and the second one I believe I'm going to use this for problem 3b. So I'm very much done from here. You can make it look better by expanding it out. So 7 squared is 49, x squared. 7 times 5, 35x. 5 squared, 25. And we are done. Now, so for this one over here, since I already know that the cube root of 343 is 7, I'm just going to rewrite my expression like this again. But this time it's going to be plus. So I'm just going to quickly write the answer like this. Plus 5. And then on the inside, going to be the minus, will be 49x squared minus 35x. So make it look better. It's 35x plus 25. And we are done. Okay, so the factor form is this is the factors form. Go here. Okay, we're done. Use the graph corresponding to a functions of the least degree. So now you have here, so this is 1 0, 2 0, 3 0. 3 x-intercepts. The absolute maximum is right here. So it looks like x equal to 0.5 and 8.5. Absolute minimum. So you have two minimum here. This one and this one. So this one is minimum and this one is minimum. And when this go up, this one has a maximum. So this is the hill, this is the valley. So the absolute minimum is the lowest minimum out of all the minimum. So this one is the absolute minimum. So we would have a negative 1.5 and -3. So number 4. So I have a rectangular box. So we have the width is 14, the length is 18. So you're making a cut and then you fold this up to the side. So if you think about, after you cut the corner and then you're gonna fold it, the box gonna look something like this. So let's see if I can do my the best I can to draw the boxes for you. So the box gonna be something like this. So when you fold it up, so this is now after you cut this and then you fold this up, the length, the height is x, and this gonna be the width gonna be 14. You cut out two x's, so you're gonna be minus 2x from the width, and the length, same thing. You're gonna take out 18 minus 2x. To find the volume, you're gonna multiply the height time the width time the length. So that would be x multiply 14 minus 2x, and then you're going to multiply with 18 minus 2x. So now we have to use Desmos graphing calculator for this. So I'm going to put in that volume, so be x multiply 14 minus 2x, and then close the bracket. 18 minus 2x, close the bracket. All right, so now let's look at the graph, and they want the maximum. So you want to look for the maximum point on the graph. It's way up here. So that is the maximum point of the graph right there. All right. So it's going to be the maximum volume will be 292 point. So we are taking the y values here, 0.86. All right, number 6. We need to put this equation in the standard form and then um, find the behavior and behaviors of this. So the standard form, you have to start from the highest exponent from the degree. So that's it. And now, without using even, we can do this without using the calculator. You can grab this in Desmos, but sometimes it's maybe too big for you to see it. But thinking about the degree, you can do this without Desmos. The degree is 13, which is odd number. Now, and the leading coefficient, is 12, positive 12. So the graph going to be like this one over here. So that's it. So when you have an even, when the degree is even, you're going to have something like this. Okay, so there's going to be both ends that go on the same directions. So this is also even degree, polynomial. And this one is odd degree polynomial. And this one has odd degree polynomial. This one's more like the linear straight line, so it's not going to be right because it's a degree 13. All right, moving on to this one. So whenever you have two end behavior that go into the opposite directions, right? For this one, it's going up. And for this one, it's going down. Then it's going to be odd right there. So if x go into positive infinity, and then y, uh, so positive first, y go into negative infinity, and if x go into negative infinity, y go into negative infinity. So this one is right, but this one is not. So that's not the right answers. Now you're moving on. So you're just trying to write it out to see what we get. So if x go into positive infinity, then this one getting go into positive infinity. If x go into negative infinity, then y go into negative infinity. So let's check. This is x going to positive infinity because going to the right. Okay, so this is going to the right. And when it go to the right, this one keep going down. So that's going to be to negative infinity. This one going to the left. So x going to negative infinity. And if the graph going up, so y going to positive infinity. So that one is wrong as well because this one is not right. This one is right. So let's check on the last one. This one is right. So you can see this one matching this descriptions. This one matching this. So this one's right. So F is right because this one is going smaller, smaller. So this one is not. This one is not going smaller. Okay, so this one is not going smaller. This one actually getting larger. I didn't see that. All right, yeah, go to number 8. Has a degree of 4. So let's see which one has a degree of 4, and one of its zero as negative 2i. All right, so let's see. So this one has a negative 2i's right here. All right, let's check all of this. So this one does not have x equal negative 2i, so we can cross this out. And now this R3 has negative 2i's. All right, let's check the rest to see what we got. So this one over here is, if you can see the scale is 1, so that's going to be 1, 2, 3, 4, 5, negative 1, negative 2. So we need to have the solutions as a negative 1 and 2. Okay, those are two real solutions. So we have to have two real solutions as x equal to negative 1 and x equal to 2. So which one has the x equal negative 1 and as positive 2? So this one, see when you solve for this one, x equal to 1. So that one is wrong. We want negative 1. So you cross this out. And see when you solve for the x plus 2, x going to equal to a negative 2. So that's another one that's wrong. So this 2 is right. Let's see. So now look at the end behavior. So end behavior. So the end behaviors, both end behavior go down. Okay, both end go down. So when both end of the graph go into the same directions, the degree is even. So that's something you need to uh, keep in mind. Uh, and also when the leading coefficient is negative, the the graph going down. Okay, so they both going down like that. So look for the negative leading coefficients. So this one has the negative side. Okay, so we're gonna take this one would be the right answer. This one is the positive. Now the graph for A would be go up like this. So they both go into the same directions. Okay. All right. So let's find the root. So the root is the x-intercept or the zero solution. They means the same thing. So we have here is so 0, then we have negative 1, negative 2 there, and 1's here. So now when x equal to a negative 2. So thinking about the graph, it's slowly, right? It's slowly flat out. Okay, so it flat out or it slowly go through the x equal negative 2. So then the multiplicity is a 3. They say the least, so the smaller. This could be 5. So when x equal to a negative 1, it just goes straight through, right? It go, the graph goes straight through it. It has the multiplicity, again, I'm not going to keep writing, is 1. And also when x equal to 0, it goes straight through again. Straight through again, it has multiplicity is 1. With x equal to 1 is bounce off. It's bounce off. So the multiplicity is 2. So for this one, they want to know is the numbers of the increase or decrease on the interval from 2006 to 2009. So you have to find those 2 years. So fatality rate is the blue. Okay, so first thing you need to know what graph you're looking at. Oh no, the birth rate. I'm sorry, I misread it. So the birth is the green. So pay attention to the green graph for number one. So 2006. So this is right there, and 2009 is right here. So now if you draw the line connect these two dots, what do you think? It's going down. So that's going to be decrease. So name one interval where fertility rate increase. Increase means go up. Now we want to look in at the blue graph for this one. So it's go up. So we can, they say just one. So it go up, we can use this interval. So the interval you have to use the x-axis number. So 2005 to 2006. Or we can say 2006, 2007. Yep, so everything go down from there. So there's a two interval that when the blue graph going up. All right, now C, the decrease. So there's many. We can name one here that is 2007 to 2008. So there's a lot more. All right, there's many more. You can figure this out on your own. Now, positive. So when the birth rate is positive, so you have to think about is um, the rate of change is positive. So we can have the from here to there. So that's positive. So we can say from 25 to 2007. That's going to be positive. So when fertility rate negative, we can have negative. We can have um, this, that. It's just so many of them. You can say 2007 to 2008. All right, for this one, what is the y-intercept? So be careful here. So the y-intercept is right here. So you want to give us a point. So 0, 4. The y-intercept, it must be a point. So if there's no complex root, how many root total does this polynomial have? What's the root includes multiplicity of the polynomial. So let's write it down. This is negative 1. This is negative 1. So this one will be 1 and this one will be 2. Then we can write it down like this. X. So x negative 1, we need to switch the sign to x plus 1. We can write in the factor and then x minus 1. So over here we have x plus 1 right here. Over here we're going to have x minus 1 there. And over here we have x minus 2. Now look, now we need to see the multiplicity where the how the graph behave. So now if the graph goes straight through, it's going to have the exponent of 1. When it's bounce off, so this is when it's bounce off, it's going to have the degree of 2. And this one straight through again is going to have the powers of 1. So now we want to see the multiplicity. So this one, I have no space. So this one has multiplicity is 1. For this one, multiplicity is 2. And for this one, the multiplicity is 1. So how many root? So the total of 4. There are four solutions. Okay, three intercept, but actually it's because the multiplicity. So if you want to write this out, you can write x plus 1. You can write out x minus 1 twice. And then you can write out x minus 2. So that's why there's four roots. There's three x intercept, but there's actually four roots. So yeah, I just explained it to you. So what's positive interval mean? The graph above the x-axis. So negative when the graph is below the x-axis. All right, let's do one more. So for this one over here, let's write the x-intercept first. It's negative 1, 1, 2. So where is the where is the ends of the graph? Where both ends of the graph going down, they both ends go down. So we're going to have the even degree. And the leading coefficients is negative. So that. So if x going to negative infinity on this side, positive infinity on this side, this going to negative infinity. This also go to negative infinity. As you can see, they're both going down, down. So the maximum and the minimum and the relative minimum and maximum. So we have the maximum, maximum, and this is minimum. So this, for the minimum, you only have one minimum, which is at 1, 0. So they're both the same for the absolute max. So because there are two maximum, the highest one is called the absolute max, and this is called relative max. So for this one is that. So I don't know. It's maybe this 0.5. This is what is it? Oh, this is negative 2. So this is more like negative 1.2. Negative 1.2, and this like 12. It's off a little bit. That. And this one is more like, more than half. So you can say 1.7 and 1 is here and about 1.5. So 1.7, 1.5. So the increase in interval is increasing from negative infinity to negative 1.2. There's another increase in interval. So again, it's increase in interval. I use different colors here so you can see. So this is increasing. And this is also increasing right there. So be from 1 to 1.7, decreasing, so it's going down. So let's use maybe different colors so you can see. May use pink. I don't know, you may not see the pink, purple. So you can see it's decrease. And start from here, decrease. So from negative 1.2 to 1. And from 1.7, again, this is negative 1.2, and this is 1.7. So from 1.7 to, again, we're using the x value, so they have to be positive infinity. So 1.7 to positive infinity.